If a quadratic equation is written in standard form, ax squared plus bx plus c equals 0, it can be solved by completing the square. This process will require 4 steps. First, if a is not equal to 1, we will divide both sides of the equation by that number. Then second, we'll move the constant term by adding or subtracting on both sides of the equation. The goal of these first 2 steps is to set up the left-hand side of the equation as a binomial so that we can proceed to complete the square on that binomial. That's step 3. To complete the square, we add the square of half of the x coefficient to both sides. This will create a perfect square trinomial on the left-hand side, so then we can proceed to step 4, and we factor and then use the principle of square roots to solve the equation. Let's look at some examples. In problem number 1, we have x squared minus 12x plus 4 equals 0. In this case, a equals 1, so we can move right to step 2, and we'll subtract 4 on both sides. So we have x squared minus 12x equals negative 4. Now, on the left-hand side, if we want to complete the square on that binomial, we take half of negative 12, which is negative 6, and then we square it. That's 36, so we're going to add 36 on both sides of the equation. Now, the left-hand side is a perfect square trinomial. We can factor x squared minus 12x plus 36 as the quantity x minus 6 squared. And on the right-hand side, we just have 32. Now we use the principle of square roots. So we have x minus 6 equals plus or minus the square root of 32. Note that since 32 has a perfect square factor, which is 16, we can simplify the square root of 32 by removing the square root of 16 and writing plus or minus 4 times the square root of 2. Finally, to isolate x, we add 6 on both sides, and we have 2 solutions to the quadratic equation. 6 plus 4 times the square root of 2 is a solution, and 6 minus 4 times the square root of 2 is a solution. We can write both of those solutions in the shorthand notation, 6 plus or minus 4 times the square root of 2 in our solution set. Let's look at a second example. 3x squared plus 6x minus 15 equals 0. In this case, a is 3. So we'll begin by dividing both sides of the equation by 3. As we do so, remember we need to divide all 3 terms on the left-hand side. So we have x squared plus 2x minus 5 equals 0. Now let's add 5 to both sides. And then let's complete the square on the left-hand side. Half of 2 is 1. 1 squared is also 1. So we need to add 1 on both sides of the equation. This creates a perfect square trinomial on the left-hand side. And x squared plus 2x plus 1 factors as the quantity x plus 1 squared. On the right-hand side, we just have 6. Now applying the principle of square roots, we see x plus 1 equals plus or minus the square root of 6. And then we isolate x by subtracting 1 on both sides. So the 2 solutions are negative 1 plus or minus the square root of 6. Let's do 2 other examples. They're slightly more difficult. Problem number 3, we have x squared plus 3 over 2x minus 1 equals 0. Since a equals 1, we'll begin by just adding 1 to both sides. And now to complete the square, we need to find half of 3 over 2. Half of 3 over 2 would be 3/4. And then we square 3/4, and that's the constant term we need to add, which is 9 over 16. So we add that to both sides of our equation. This creates a perfect square trinomial on the left-hand side. Factoring the left-hand side, we have x plus 3/4, the quantity squared. On the right-hand side, in order to add the fractions, we can write 1 as 16 over 16, and then add 9/16 to obtain 25 over 16. Now if we take the principle of square roots, we will have x plus 3/4 equals plus or minus the square root of 25 over 16. We can simplify that square root, since both 25 and 16 are perfect squares, to plus or minus 5 over 4. This means we have two equations to solve. X plus 3/4 equals positive 5 over 4, or x plus 3/4 equals negative 5 over 4. In each case, we need to subtract 3/4 from both sides of the equation. In the left equation, we have 5/4 minus 3/4, which is 2/4, or 1/2. And on the right equation, we have negative 5/4 minus 3/4, which would be negative 8 over 4, or more simply, negative 2. So this quadratic equation has two solutions, negative 2 and 1/2. Finally, in problem 4, we have 2x squared minus 10x plus 3 equals 0. Let's begin by dividing both sides of the equation by 2 to obtain x squared minus 5x plus 3 over 2 equals 0. Then we will subtract 3 over 2 on both sides. And to complete the square, we would find half of negative 5. That's negative 5 over 2. And then when we square that, we get 25 over 4. That's what we need to add on both sides of the equation. Factoring the perfect square trinomial on the left-hand side, the quantity x minus 5 over 2 squared. And then on the right-hand side, once again, to add these fractions, we need a common denominator. Let's rewrite our first fraction as negative 6 over 4. And then if we add 25 over 4, we have 19 over 4. Now we can apply the principle of square roots. So we have x minus 5 over 2 equals plus or minus the square root of 19 over 4. And since 4 is a perfect square, we'll simplify that to plus or minus the square root of 19 divided by 2. Lastly, to isolate x, we add 5 over 2 on both sides to obtain x equals 5 over 2 plus or minus the square root of 19 over 2. And we can either write the solutions in that form as two separate fractions, or since the denominators are the same, we can add the fractions and write 5 plus or minus the square root of 19 all over 2.